Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to add support for wheeled vehicles into our physics movement component. This, I think, is the third part of a multi-part series on adding wheel support into our physics simulation component. The first part was creating a little system to allow us to change the mass properties of our vehicle. You can see here our vehicle's kind of skidding around a little bit on a very slick surface. The second one was creating a engine simulation so we can take the throttle input and convert that to torque. And I think in this video we're going to revisit that engine simulation just a tad. After doing the video and continuing to play around with the code a little bit, I found created some other slicker ways to manage the torque. So we'll go ahead and add that in. And then in this video, which is what we're really trying to do in this video, is actually working on transmissions and torque distribution between the front wheels and the rear wheels. So that's what we'll be working on. So we'll be taking the torque that we're creating through that engine simulation. So the input control is going to the engine is going to be creating torque based on how much throttle we give it, and then we'll be creating a transmission system, and this transmission system will be able to support both manual and automatic transmissions, which can then take that torque and turn it and pipe that to the wheels so that we can create rotational velocity as well as angular positioning for our wheels. And ultimately that will then translate into friction forces, which will then move the vehicle across the ground. So as always, we have a lot of ground to cover. So yeah, let's get started. Alright, so before we get started, let's do a little bit of housekeeping. So in the previous video, we went ahead and started stubbing out our wheel vehicle, and that is coming off a UObject. And we're using this, there's two macros or compiler macros that we could be using, and we're actually using the generated U-class body. And this macro actually creates some functions under the hood, and one of them is a constructor. And in the last video, I forgot to add this. We're doing a lot of different things, and so I forgot to add this constructor. So if you did the last video, tried to compile it, and you were starting to get some linker errors, it's probably because we were missing this. So just add this function here, which is the constructor, which gets added, and that should solve that issue. The second piece of housekeeping that I'd like to do is in the engine. So when we created the engine, I had this torque curve multiplier, and as I've been kind of working on improving the engine simulation and trying to make that better, I came out with something a little bit different in doing my research. So I'm actually going to be taking this torque multiplier out because we don't really need that here, and then instead we're going to be working more with the max torque instead. So the multiplier's out, we've got the max torque here, because we really weren't doing much with max torque. And so then I'm going to come back to our implementation in the get torque from RPM function. Since we don't have this anymore, instead what I'm going to do is I'm actually going to use the max torque instead. And then I'm also just going to go ahead and get rid of all of this, and I'm just going to return max torque. So if there's no curve, we're just going to return the max torque, but if you want to use a curve, we're going to use this instead. And one other thing, just to make lives easier with the curve, I'm going to go ahead and scale down the RPMs. So what we'll do is we'll take in the RPMs, which are going to be in the thousands, and we're going to divide by 1,000, which would then give it a, kind of move things to so 1,000 RPMs would technically be 1 on the scale. And this will make making those torque curves a little bit easier. But yeah, again, I was doing some research on trying to improve my engine simulation, came to some revelations there that this is something which would actually work a little bit better. And so this is actually going to allow us to you can then create the torque curves of your favorite sports cars or vehicles, right? If you can get and then you can then use that actual curve for the power drop off, and then you can actually use the actual torque that it's creating here. So that's kind of what we're going to do there. All right, so those are the two housekeeping items that I needed to do to change. So now that we've got that done, I'm just going to go ahead and compile to make sure everything's still good, and then we'll continue with creating the transmission and power differential simulation code. All right, so let's go ahead and compile. So I've got the project open here. So before we do the compile, I know some people, if you're new to C++ and you've been kind of following along and do a lot of compiling and then suddenly wonder where your project stuff has gone, once you reopen the project, check to see if enable live coding is turned on. Oops, looks like my controller just disconnected. So go away. So check to see if this is turned on. I usually turn this off, and as you can see here, hot patches, C++ functions. So what this does is it creates, every time you compile with live coding on, it creates a hot patch. It's a temporary thing, and then if the browser actually closes, and you reopen it, all that hot patching is usually gone. So I usually turn this off. Once you turn it off and hit compile, then it does a full compile instead, without any of this stuff. So I usually just turn this off for compiling code. So I'm just going to hit the compile button after that. Could compile. All right, so let's go ahead and add the transmission and power differential into our code. So let's go back to our solution. So here it is. All right, so I'm now working in the simulation configuration. So this is where we've been keeping all of our stuff. So I'm going to go ahead and move the engine simulation. I'm just going to minimize. Actually, let's get a little bit of white space between that. Make it a little bit easier. I'm just going to go ahead and minimize this since we're not going to be in the engine simulation now. We've already got that taken care of. All right, so let's start off with, I think the first thing is going to be the differential. So I'm just going to bring over. So the first thing on my differential code is going to be an enumerator. As you can see, I really, really love enumerators. It's a great way to allow me to configure things in blueprints, and it gives you this with Unreal Engine enumerators, which are blueprintable. You can then see what you're actually setting your flags to. So this is going to allow us to do freewheel, all-wheel drive, front-wheel drive, and rear-wheel drive. Freewheel pretty much says that there's no power to any of these wheels. All-wheel drive says every wheel is going to have power. Front-wheel drive is going to be, again, wheels that have been designated as front wheels will have power. Rear wheels that have been designated as rear wheel will have power. So that's kind of how that's going to work. So that's the configuration there, and this is our differential setup. Next is going to be the differential code. So let's go ahead and grab that. And all this is, let's go and change the API to get rid of these red squigglies. So here, I think I'm calling this physics wheel. Let's see, what am I calling this? Just make sure, as you can see here, there's a reference here to our wheel, so we'll be coming back to our wheel, and because of that, I think I just need to go ahead and put. Yep, we need to do that. Let's go ahead and add the include. And where are wheels? Let's see. I think it's under vehicles, vehicle wheels. There we go. All right, so we got that reference in there, so that should be happy. All right, so as you can see here, we're actually going to be passing in references to each wheel that we'll be applying power to, and so that's how we're going to then do our apply torque differential to it. And as you can see here, so this is going to be how I'm going to do my front rear split. And as you can see, so one, if we shift this to 1, it's going to be all front. If we shift it to 0, it's going to be all rear. and then anywhere in between will be creating a proportion. And so what it's going to be is that we're going to create them. We've got our torque, and then so if we're moving forward, it'll be torque plus, and the rear wheels will be torque minus. And if we're moving back, it'll be the front will be torque minus, and the rear wheels be torque plus. Yeah, we don't want to lose, and this way we don't want to lose the total amount of torque in the system. We just want to make sure that we change how much is being applied to each wheel. So that's how that's going to work. So we have one public function here, which is apply torque to differential, and that will be hooked into our simulation code. And then we have two little private functions, which will determine how we're going to go ahead and calculate the amount of torque for front and rear. So as you can see here, get front torque is our first private function. It returns a double. And I've just inlined it since it's a pretty simple equation. So all we're going to do is we're just going to take the torque that's coming in. This is the torque that's coming off the engine, right? And we're going to double it first, and then we're going to then multiply it by the front rear split. So if it's a 50-50, we double it and then we just halve it again, and then that gives us the torque. But if we're moving more to the front, we'll double it, and then we will then multiply it by a little bit more, which will then give us a nudge more torque on the front than we will on the rear. So then with the rear, the equation is taking the torque, doing the same thing. We want to double it first, and then we'll then say, okay, get front torque, and then so we'll then subtract from the rear the amount of front torque that we're adding. So then that should shift the amount of torque between the front axles and the front drive axles and the rear drive axles to kind of get us the balance that we want. All right, so, and that's it. So then the only thing we need to do here is to apply the torque differential. So I'm just going to go ahead and let's go ahead and do that now while we're here. And I'm just going to go find that code. All right, and as you can see, we've got a lot of things that we need to add to our wheel as well as to our axle type. So we've got some additional things that we need to add to the wheel here, judging by red squigglies. So we'll go ahead and do that so we can toggle this code. But I kind of wanted to get this in here first so we can see what we need, the additions that we need to add to our wheel profile. So we'll need to have an axle type on our wheel profile, so we know that this wheel is tied to this axle, right? Is it a rear axle or is it a front axle? So, is it the front set or is it the rear set? Or is it a free axle? So a free axle, what I've defined as a free axle is an axle without power, which would never have power. Technically, you could say that the front, you could just say that these are just rear axles and everything else is a free axle. Or you could say the front axle, rear axle, and whenever we do when we start creating the wheel setups, we'll determine, based on the differential, how to set up what's enabled and what isn't. But again, so we've got some things that are missing, so let's go over to our wheel and satisfy the missing requirements. All right, so let's go over to the wheel simulation. And I will go find that wheel simulation over here. All right, so let's see. We need an enumerator for the, let's see, we need a numerator for our ePhysics axle type. All right, so let's go to wheels, and I'm just going to add it right here into the file just to keep everything together. So that's our axle type, which should then satisfy that part of the equation. So now we need, in the wheel profile, we need to add an axle type. So let's go back over to wheel, let's see. That should be, I think I moved that into a vehicle simulation component wheel simulation setup. Yep, that's right here. So we'll pull this up and we'll see. Okay, so this is where we're going to need to add our configuration type here, because that's where I'm keeping the configuration data, is in this struct right here. So let's go over to the setup and add that real quick. Actually, I'm just checking my other code. I'm going to go ahead and take this out of here. So I'm going to move this out of the wheel, and I'm just going to move this over to the simulation setup, over to the struct instead. Since the struct is what's actually, this is residing in the struct and not necessarily in the wheel, and the wheel's referencing this anyway, so that should follow through. Just double check. Yep, still good. All right, so let's go ahead and add our axle type. So this is just going to be a little property, and I'm just going to go ahead and add that here. I like to keep anything which is non-blueprintable and below the blueprintable stuff, so it's just a way for me to kind of get a quick I see what's available in Blueprint versus which is configurable versus what's actually going to be hidden away a little bit, so that we can I still want to be able to read this and write to it from the simulation code, or read it from the simulation code, but I don't necessarily need the user to set this, because what we're going to be doing, we're actually going to use the differential to determine whether this wheel is going to be set up or not, and that's based on us defining in the wheel this this flag here, whether it's undefined front or rear. All right, so that should do it for the extra variable. So let's go to our configuration into the code, and as you can see, that solved that problem. So now what we need is just a variable to set the drive torque. So let's go back to our simulation code. And again, this is going to be on the profile, so let's go up to the setup. So we put the omega in here, so this is us getting the wheel RPM, which is the omega. But another variable that we're going to be adding, so that as we calculate our simulation, is going to be the drive torque, and that's going to be in Newton meters. So that's going to be in Newton meters. Everything here is pretty much metric. So Unreal Engine calculates everything in metric. So we're just going to keep everything in that scale. So that's Newton meters, and now we need a way to go and set this as well as get this. So let's go ahead and create that function. So I'm just going to come down here. I'm going to do a getter. Again, this is going to be getting, this is the setter actually, which is going to set the drive torque. So I'm going to put a value in, set the drive torque. And then I'm also just going to do a getter to get the drive torque for anything that needs to get it. So those kind of mirror each other. So I'll just keep those together like that. All right, so that should satisfy the drive torque. Again, we'll be adding more and more variables into this system, and eventually we'll finish up the this whole series with the working on the wheel simulation. This is going to be the last thing, but I think it'll be good to kind of see all of the things that need to contribute from all of the other systems that we're going to be creating in order for us to start calculating the wheel friction, which would be done here in the wheel simulation setup. So we're getting our drive torque, and this is the amount of torque that's coming off the engine, right? And this is the amount of torque that we want to send in, which is going to then, in which our wheel simulation will take that drive torque and translate it into thrust or friction forces, which is thrust to move the vehicle forward. All right, so let's see, that takes care of that. So, all right, so there we go. So our differential code is all done. And as you can see, there it is. So what we do is we check the differential type on the wheel. So if we have a good wheel, we're going to check our differential type. And the differential type is set up in the configuration. So this is part of our configuration. So when we go in, we'll set the differential up on our vehicle. So this is what we'll say, and then from there we'll then, based on the wheel, we'll check to see what the wheel is configured to, and if the wheel is configured correctly, we'll give it torque. So if this is set to rear wheel drives, then we'll only give torque to the rear wheels and we'll ignore the front wheels or any free wheels. If it's front wheel drive, we'll ignore the rear wheels and set it only to tires that have been set to front. And then if it's all-wheel drive, then we'll look for both front and rear, and that's when we'll also have to do our get front torque, get rear torque based on the slider that we just created. And then again, like I said, if it's set to freewheel or undefined, we'll set that drive torque to 0 because there's just no torque there. It's not providing it's not going to be providing thrust. It's just going to be rolling on the ground. All right, so that should do it for the differential. So now let's go into adding our transmission. So let me go back to our code real quick. That's vehicle simulation component. Let me see if I can just find it. Got lots of code here. There it is. All right, so that's the differential. So for our transmission, again, I'm just going to start off with an enumerator. I'm just going to close this and close that so we can focus on this. So this is our transmission. We have two types. We have a manual transmission and an automatic transmission. So we'll be able to support both of those transmission types within our simulation here. And for our simulation, and this is going to be a rather large strut, so just bear with me real quick, and we'll go over each piece of it. I'm just going to bring it in. Nice. Told you it's going to be a rather large struct. And of course we just need to go and change the API. All right, so this is how we're going to define a transmission. So this is our transmission simulation. So as you can see here, I've got in the constructor, I'm just going to go ahead and put a forward ratio and a reverse ratio. So these are the gear ratios, right? And this is how we're going to define how much additional torque to the final gear size that we're going to apply. So when we set up our gears, we're going to need forward gears, and if we want to go backwards, we're going to need some reverse gears, or at least one reverse gear to go back. So, and by default, we're just going to put 2 in there and just set them to 1. All right, tag and tag name and enable again. This is just something I'm putting in there, just so I can find it and turn it on or off. Next, transmission type. So as you see here, we had our enumerator, which is manual and automatic. And what we have here is we've got, so here this is where we can set it, right? So is this an automatic transmission or a manual transmission? So again, this will, so this is how we can set that, configure that in the blueprint. Final ratio, this is the final drive ratio. So this is the final, it's not the final gear, right? It's going to be the final, this is the size of the final drive gear, which is going to be turning. I'm just going to set that to 4. Because that's, so that's a default. So this is the final gear that your vehicle is going to be using in order to push across the ground. And you might, for larger vehicles like the RV that we're using, the recreational vehicle, you might need to make that final gear bigger in order to transform torque into into thrust effectively. For smaller cars, this final gear may come down a little bit, but this is our drive gear. Next, we've got our gear ratios. So again, these are the ratios to that final gear. So the way this is going to work is we're going to take this ratio, multiply it by the final gear, and then that will give us the amount of actual torque based on the size of the gears, the gear that we're using in order to push the vehicle or forward or back. So this is our forward ratio, this is our reverse, and it's just an array. So if we want an automatic vehicle, we need to know when to do our shift. And these are just some defaults, but this shifting is usually based on the torque curve, and we'll talk about that in a later video when we start setting up the vehicle and showing you how to set up your torque curves. So based off those torque curves, that's where you kind of want to then figure out where you want to shift up and where you want to shift down. So when the vehicle hits 5,000 RPMs, right, that's when we'll shift up to the next gear. And then if we drop below 2,500 RPMs, right, that's when the simulation will try and shift us down into an optimal gear. And the idea here is really to create a simulation with an automatic gearbox to keep us at the optimal, to get us up to and then maintain that optimal torque coming off the engine. Gear shift time, this is just lag. So based on if you wanted to have something which is feels a little bit more, if you want a race car, you're probably going to take this lag and bring it down, make it really small, because so it shifts to neutral and then into its new gear faster. If you've got something maybe like a tank where it might take a good second or 2 seconds, or a good second or half a second for that thing to shift, you could then we can then try and simulate that. And then there's always the transmission efficiency, right? How much is going to be lost to friction, and that's kind of what we're setting there. As far as functions, and we'll get to implementation on after we've talked about it. But first off, we've got our set gear. So, and again, if you're new to C++, we can one of the nice things is we can actually set a default. So as you can see here, this is set to default of false, is immediate. So this could be something where you may need to set that gear immediately at the start of a game, just so that it's in first gear versus waiting for the gear lag to bump it up. So you could do that here. Otherwise, it's set to false, and if it's set to false, then we will be using the shifting time to shift, to figure out when to shift that gear, and that's going to be shifting time against the delta time of our simulation. Shift up and shift down, pretty simple. We have a target gear, and they were either target gear +1 or target gear -1. So this is going to say, whether we're shifting up or shifting down. And then we have the ability to set allowed gear to change. So this is a way for us to determine whether we can tell the transmission to be able to shift or not. So for most part, we'll be setting this to true, but there could be times in the simulation where we may need to say, no, you can't shift at this point in time until some other criteria has been met. But for now, I think we're just going to do an auto, allow you to shift without any other criteria. Get current gear and target gear. So current gear is always the gear that we're currently in. Target gear is the gear that we want to be in. So this is how we're going to determine whether we need to shift up or shift down based on the gear. And then here is the equation or the logic that we need. So is current gear shifting gears? So if we're shifting gear, it means that we've changed the target gear, and the target gear is no longer equal to the current gear. And if it is, then we will then run the simulation to shift the gear so that both these values are in sync again. Then is out of gear. This is check to see if our current gear is set to 0, which is neutral, or are we currently shifting? So if we're imbalanced, so this is just a Boolean check to see if we're currently out of gear or not. So if we're out of gear, it means that we're shifting between the gears, right? Or our gear is set to 0, which means it's neutral. Get gear ratio. This is pretty much going in there and figuring out if this is the gear, what is the ratio that we need to be at. So if we're at if we put in gear 0, we're going to be 0. Then it's 0 ratio coming back because we're in out of gear. If we pop it into first gear, then it's going to go into the array and find the first gear, or second gear, third gear, fourth gear in the system. Or if we're in reverse, we'll put a -1 in there, and then it'll look into the other array to find that gear. Get transmission RPMs. So again, this is getting the amount of revolutions coming out of the transmission. So this is the spinning of the axle, and that's based on the gear. Get the transmission RPM. So actually I have an overloaded function here. So in C++ we can do overloaded functions. So this one is actually just doing the same thing as we're doing here. So instead of having to provide it these two variables, I can just go ahead and just call this, and it's already going to provide the internal variables that we need versus setting the external variables. Then we have get transmission torque. Again, this is the actual torque coming off the transmission, not the RPMs. So two different variables. And then this is the get RPMs from wheel RPM. So this is trying to figure out what the actual spinning of the drive shaft is based on the wheels that are spinning. So then we have a simulation, then we have simulate, and that's the delta time, and then we have get correct gear input. This allows us to figure out what the actual gear is. So if we have 6 gears and we try to upshift and we do an upshift, well, if we don't have 7, if we're in gear 6 and it tries to shift us to 7, this will tell us no, you need to stay in gear 6. So this just keeps us within the arrays. That way we don't bounce beyond the arrays. And then as far as the private variables, these are the variables that our simulation are going to be using. So again, this is the data that we're setting and getting, right? And this is what our simulate is going to be using right here. All right, so let's go ahead and set this up a bit. And it looks like for simulate anyway, we're going to have to, I'm going to have to do a copy paste. But apart from that, I think everything else looks like it's a green squiggly. Let's make sure it's going to put it in the right place. Simulation configuration, yes. Let's see, let's simulate engine. Let's simulate engine. Yeah, no, kind of missed the mark. Visual Studio again. So I'm just going to go ahead and just cut that. I'm just going to minimize this a little bit. Actually, I'm just going to put that down there. All right, so set gear. Let's go and put in the implementation for our set gear. So as we set the gear, I'm just going to go and do that. So we're going to take a gear in, and is immediate. As you can see here, we're not going to worry, well, we're going to take a look at this to see if we need to immediately shift it or if we are going to be shifting it using the lag time. So I'm just going to grab this and I'm going to put that in. So as you can see here, we're going to use this get correct input. And that is going to, what's going on here? So we're going to be using this function get correct input range. I think maybe I'll do that next, so we kind of see what's going on there. But that's going to take the gear and it's going to make sure, and it's an output. So we put the gear in and then it's going to output the correct gear. So if that's the right gear, it'll output it. Otherwise, if it's the wrong gear, it'll do a min max to try and figure out which gear it should be, so we can set that as the target gear. So this is how we're going to be setting that gear, the target gear. And then the target gear, we're going to check to see if the target gear and the current gear are a match. If they're not, that means we're shifting. And so if we're shifting, we're going to check to see if this is an immediate shift and the gear shifting time, or, and that's what these two little pipes are in C++. If you're new to C++, if you want to do an or, it's 2 pipes, and are 2 ampersand signs. Or we're going to shift, check to see if the shifting time is 0. If it's 0, then it's it's pretty much immediate. And so we're just going to go ahead and say target gear is equal to current gear. If it's not, that's when we'll start using the shifting time and set the shifting time. And this is what we will be then counting down in the delta seconds until we know when to actually perform this in the simulation. All right. So next, let's go back, and I'm going to go ahead and do the correct gear range input next. Again, wrong. Visual Studio's IntelliSense. Not very intelligent anymore. Alright, so for this one, this is just correct gear ratio. It's just this is just should be pretty simple. Just gonna go grab this from the other solution. Alright, so here again, we're using an ampersand. Whenever we use an ampersand, if you're new to C++, if we use an ampersand here, this is now an output versus just a strictly input. So we can put it in, we can check it, and then we can pop it back out again. So that's what that's for. So here we're going to take we're going to take this output, and we're going to clamp it between the number of this number and this number. So this is the array number. This is the number of gears in the reverse ratio array, as well as the number of gears in the forward. So this would be 1, 2, 3, 4, 5, 6, and this would be 1 if we're using a 6-speed transmission with 1 reverse. So if this comes in a 0, well, it's between that number, and so it'll pop out. If it's 7 and it's its forward ratio of 6, it will clamp it back to 6. If this comes in as -2, we're trying to put it into a second reverse gear, it will pop it back to a reverse gear of 1. Or -1, which would be the pop it back into that gear. So it's just going to make sure that we just clamp that, so we don't go beyond the ranges. All right, and that's kind of what that's doing here. So I figured I'd come back, show this one, because we'll be using this just to make sure, just to validate everything that we're doing. Alright, so next in configuration, let's go back. Let's see, so upshift, downshift, engine RPM, all of these are just inlines, so that looks good. Get gear ratio. Alright, so that's the next one. I think I'm just going to take this from the other solution versus fix the squigglies. So getting the gear ratio. So we have set gear. This is getting the gear ratio. So we need to go into, based on the gear, we need to find that its value, right? So that we can apply the right ratio. So again, we want to do a check, just like we did for set gear. We want to make sure that our the gear number is within the range, within the acceptable range. If the gear is positive, right, above 0, then we're going to use the forward ratio. So it's get gear -1. So arrays are 0 based. So 0 is technically the first gear, but if we put 1 in, then we would technically be it would send us to gear 2, which is not what we want. So to solve that, we just take the gear number -1, and then that will give us what we're looking for. And then we multiply that by the final drive ratio. This is the final drive. This is our drive. This is the final drive gear, and this is the size of the gear, right, that we're using. And then again, if it's less than, it means we're going in reverse. So if it's -1, so then all we're doing is we're just taking this. We need to find it in an array, so we're going to take the absolute of this gear, because we need to find because arrays are positive, and again, that's when we do the same math value here. Find the gear, multiply it by the ratio, and then because we're going backwards, we need to make this negative. So that's why I'm multiplying it by -1. And then if the gear is 0, it's neutral, we're going to just return 0, which means that the vehicle will not be providing any torque if we're in neutral. All right, so that is getting the gear ratio. Next up, I think, let's just double check, get the transmission RPM, so we can do that. So here's our get transmission RPM. So again, we're taking the engine RPM and the gear. We're going to check if the gear is 0. Well, that's pretty simple. Then we have no revolutions. or we don't need any revolutions, so our revolution is 0. Otherwise, it's going to be get the gear ratio, which is up here, which is going to go ahead, get all that information, and then we divide that by the engine RPM. And then that should be the transmission's revolutions per minute. So this is the revolutions of the drive axle. All right, what's next? So we've got this, get transmission torque. So now we got the revolutions, but we need to know how much power is actually coming through that drive axle. All right, so this is the torque. So again, we're going to be putting a torque in, get gear ratio again, get the current gear in order to know what the gear ratio is, and then we multiply that by the torque efficiency or the transmission efficiency. So whatever we get back, we also then want to, this is where we'll then say, okay, well, this isn't 100%. There's friction in the system which is causing torque to, we're losing some of the torque, right? So if we're losing some of that torque, then this is what's going to take some of that torque off for us in the simulation. All right. So that's torque, this is revolutions, this is torque. Okay, next up is going to be getting the revolutions per minute from the wheels RPM. So this is how we're going to figure out how much the torque is, how much we're spinning based on how much the, so it's kind of like a feedback, right? We're putting revolutions onto the system, but we also need to figure out if we're freewheeling down, whether what is the axle really going, because axle can technically go faster than the engine a little bit, but then the engine would then start bringing in braking factors, depending on if you're in gear or not. So if we take the vehicle out of gear, if we're in neutral and we're rolling downhill, technically we should still have revolutions on that drive axle, even if we're not in gear. So to do that, get current RPM from wheel. So this is just doing that. So again, this is getting the gear ratio. Everything's based on the gear ratio, as you can tell. So all these functions, and then this is the wheel RPM. So this is going to be the wheel RPM based on the gear ratio. So that's going to be the engine's RPM based on the wheel. Or, well, it shouldn't really be the engine's RPM, but it's based on the wheel moving. All right, so after all of that, the last function is the function that we're going to be using to try and simulate our transmission. So we're just going to bring that one in. All right, so first we're going to check to see if our transmission is enabled. If it's not enabled, then we won't run anything. If it is enabled, then we will proceed with gear switch, shifting a gear. So if we are automatic gear, right, or automatic transmission, then we have to do then the simulation is going to be taking over and it's going to do our upshift and downshift for us. If we're a manual transmission, then the only thing that we really care about is just making sure that target gear, check to see if these aren't synced up. If they're not synced up, then what we'll do is we'll then take the delta time minus the shifting time, right, and then determine whether we should be shifting. If we're less than or equal to 0, then we will set the shifting time back to 0 again, so we can restart the simulation, and then we'll make these gears equal, which will then say, okay, we've now shifted. So that's manual. For automatic, we need to know the upshift, downshift, and once this is done, then we can then still do the same part. So we're just simulating that automatic piece here versus having manual inputs come in to set the gears. So the first thing we'll do, if this is an automatic, are we already shifting? If we're already shifting and we're allowed to shift, if we're already shifting and we're not allowed, and we're allowed to shift or not allowed to shift, right? Both of these have to be in agreement for us to do an auto shift. So if we're already shifting, don't worry about it. That's when we come down to here and do the delta time here. Otherwise, if we're not shifting, okay, and we need to do the shift, then it's going to take a look at, this is the current engine RPM, it's going to take a look at the shift up RPM, so this is our ability to shift our gears up. If our RPM is greater than or equal to the shift up, then it's going to say, okay, we need to go ahead and shift up the gear. So current gear is equal to 0. Right, we're going to shift up. Otherwise, we're going to shift down. And this is if we're in gear 1, if we're in gear 1, or if we're in reverse gear. And that's why we have a shift up, shift down. So if we're shifting down, we should be shifting from neutral into reverse gear. If we're shifting up, we're shifting from neutral into first gear, second gear, third gear, fourth gear, fifth gear, etc., etc., etc. Else, if the revolutions are less than the shifting and our current gear is greater than 1, right? And this is the absolute, right? So what we, so if it's -1, we're going to take the absolute. We're checking to see if we're in gear and our gear is either in reverse or not in reverse. So if our current gear is greater, then we're going to shift down this time so that we can get into a lower gear, because we need to get those RPM. We want to get the revolutions back up again to get us back to optimal torque. Otherwise, if we're in reverse, then we're going to shift up, right? And we're shifting up into, so then we'll be shifting up. Actually, no, take that back. If our gear is greater than 0, if our gear is greater than 0, yes, we'll want to shift down in order to get up. And then it's the opposite, right? If our gear is less than, we want to shift up in order to get us back into neutral, and then, or shift up actually through the reverse gears. That's what I meant to say. We want to shift up, but we're shifting up through the reverse gears and not through the drive gears. So that's kind of what that does. All right, so that should do it for the simulation part. So now that we've got our transmission defined, and I should take a look and make sure all the green squigglies are gone, we should have all of our functions defined. Okay, so now what we'll do is we'll then hook this into the simulation, into our simulation component, so that we can then set it when we're ready to start building out our vehicle, and then we'll hook it into all of the pieces that we need to hook it into, so that we can take this energy and apply it to the wheels. Okay, so in order for us to tie this into our physics component, we need to add some input variables to our network traits. So this is our vehicle movement traits. So we have a couple of things in here that are set up so that we can use this to pass information from the game, from our game thread to the physics thread. And also, if we decide to network it, these inputs should also go up and down the network too. So let's go ahead. So as you can see here, throughout all of our vehicles, we've been pretty fortunate to not have to add too much more to this. But as you can see here, when we start getting into engines, we needed a separate one for engine throttle, because this is going to a separate engine input versus the thruster throttle inputs. So now when we're dealing with transmissions, we're going to need a couple other inputs as well, and I'm actually going to bring 3 in. So, and I'm just going to put them down here. And those inputs are going to be our upshift, downshift, and then transmission type. I'm choosing to include the transmission type here. This would be something that if you wanted a player to be able to switch between automatic and manual transmission actually in the game, you could do so. This is kind of a little bit more arcade-like maybe, but if someone is learning to drive using the manual, but then they suddenly are finding that they want to switch over mid-game, you could put something on the controller, a button on the controller to help switch the transmission type. So that's what that's there for. But yeah, shift up, shift down if they're using manual transmission, or if you wanted to have them pop it in from neutral into drive and then have the automatic takeover. I think that's what I'm going to do here. Or pop it out of neutral, pop it from drive to neutral and then down into reverse. You could do that. We need to be able to pass inputs from the from the game thread over to the physics thread so that it can then do that simulation. So those are those two inputs that we're going to pass in here. But like anything else, I'm going to go ahead and also come over to the vehicle physics or vehicle net phys move state. So this is the data in the data packet that goes up and down the network if you decide you want to try and network this. And this is how we're going to decay the rate if the data packet starts getting stale. So to do that, so the only things that we're going to do on decay, so we don't, because they're Boolean values, it's either it's there or it's not. So it's going to get consumed as soon as it gets used. So I don't really need to try and interpolate a Boolean value. So as you can see here, we have the throttle input, but we really don't need to add the inputs for the gears. But we will add them in for shifting purposes. So under the engines, so again, so what this does is this is how interpolation determines whether the network, the data that it has is getting stale. So as we continue to make input updates, we're going to be creating this archive, right? And this is the archive that, for each vehicle, for each network packet it's managing to figure out whether that input is getting stale or not. So if this keeps getting refreshed, it's good. If this is, on tick has not changed, there's no change between it, then it's going to realize that it's getting stale. So then it's going to then do a decay. And then after the decay, it'll then do the next thing, which will be interpolate. Now, while we can't really decay a Boolean value, I am going to put in the interpolation for the Boolean value. So I'm just going to go and add that in there. So there is an interpolation here. So we can't really decay it, but we can interpolate it. And by interpolating it, we will then determine if this Boolean value is going from true to false, right? Based on its interpolation between the value. All right, so that should be it for the networking piece. So that's our movement traits. We've added three in there, and again, I'm not going to interpolate or decay this. Am I including it? And I'm actually not going to include this transmission type update in the data packet either. The only things that are really going to be shifting a lot are going to be this, and probably not that, so we won't include that. All right, so that should be it for our network traits. So now that we got the network out of the way, we should be able to move straight into our physics simulation component and start hooking this all up. Okay, so now we're in our vehicle simulation component. So this is where we're going to be hooking everything into both the game thread and the physics thread. So the first thing we need to do is we need references to our simulation components. So we have the simulation set up for the engine. So let's go ahead and add the components for the transmission and the differential. So I'm just going to bring those over real quick. So the first one is I'm going to go ahead and just bring the transmission over first. It's just kind of how I like to think. So it goes engine, then transmission, and then I think differential kind of goes below the transmission. So I'm going to do that, hit save, and then that should automatically come in. Just put a little bit of white space between that, or black space. All right, so there's the transmission simulation, there's the differential. So there's the two new components that we're adding into our simulation. Then next, we don't need to worry about throttle configurations. We have the engine throttle, but we don't need anything for the gear up, gear down, because that's going to be that's actually being handled within the system. Through the simulation. So we don't need to worry about any input rate configurations here, since it's all pretty much booleans. Next, do we need anything here? Yes, we do. So what we're going to do under, so we have the, so in the throttle, we were piggybacking off our set throttle by adding another input access, right? But for shifting, we're going to need some functions so that we can put the right shifting values in. So let's go ahead and get that. So I'm going to add two functions. And I will put it underneath, above the set simulation. So this is the new one, which is the set gear shift. So, and this is going to be whether it's an upshift or a downshift. It's just one function, and we just use a Boolean value to say, are we shifting up or are we shifting down? And then I've got the transmission type as well. So if we want to change the transmission type, we just change it here. So those are two new functions. And we also need some new private variables for raw inputs. So for that, I'm just going to go ahead and grab the transmission update. So that is what for transmission type update. And all right, so we're going to just do this. So we've got upshift, downshift, and then we have the transmission type. So as you can see here, we have a little bit of a kind of a mismatch. Here we're using an enumerator, but here we're using an 8-bit integer. And that's also tied into our movement traits as well. So if you kind of noticed here, it's an 8-bit integer and not the enum. And that's because when we serialize to send it up and down the wire, you really can't serialize when you really can't serialize an enumerator. But enumerators, as you can tell, if we come back to our thing here, are deriving off this integer value. And so this is kind of what we do. So this is considered 0, this is considered 1, right? If I hover over there, you can see this is an integer of 0, of unsigned 0, this is unsigned 1. And so that's what this is here, all right? And you can set this, so sometimes you'll see this as uint8, which means it's going to be an 8-bit integer. You can see 16s, 32s, and even up to 64, right? Depending on how large this enumerator is going to get. And that's all we're going to do. So we can't send this guy up and down the network, but we can certainly send an integer up and down the network. And so then what we'll then do is when we get this, we'll have to then cast it back into the enumerator to get the actual enumerated value. So that's kind of what we're doing there. So that's why we've got this as an 8 here, so that we can then send it up and down the network. All right. Okay, so those should be the new inputs for now. So let's go ahead and go into the implementation side and start hooking this all together. Okay, so in the implementation file, first off we have the simulated physics tick. We don't need to add anything here, so this is everything that we're going to be executing on the physics thread. Stop movement immediately, we don't need to worry about that anymore. We've got all the things we need in there. Create wheel setups, again, we'll come back to this a little bit later, but we don't need to add anything here for the transmission. Don't need to worry about anything else here. So the first thing we need to do is we need to come down to our wheel state GT, and we need to add some additional things in here now to help us with the transmission simulation. So what we've done here is we've gone ahead and done the engine simulation. So this is taking the throttle input so that we can and this is being updated on the game tick. So this is on the game thread, this is being updated. So what we're doing is we're taking the raw inputs and we're just interpolating that value based on our little throttle setup. to get a true number back here that we're going to pass on to the game thread or to the physics thread. So now we just need to do the same thing for our transmissions. And so we really just need 3 things. So I'm just going to bring those over. And again, we'll be adding more and more to this wheel state GT as time goes on. But as far as the inputs for transmissions, this is what we're going to be doing. So I'm actually going to be consuming this this value, right, on the game thread, but I don't want to change it until I know that it's been successfully consumed. So to do that, what I'm going to do is I'm actually going to check to see if the upshift and if the downshift is set to true. So as long as they're not set to true, if they're set to false, we'll come in and we'll take the raw shift and we'll keep updating. And as you can see here, we'll keep updating and setting the raw to false. But as soon as this goes to true, we actually lock this on the next tick, so we can't execute any of this. And then what is going to change this is this will get changed on the physics thread to unlock it so that we can then run this code again. So that's how we're going to do it for this simulation. And then we're going to do it for the upshift, and then the same thing for the downshift using the raws. And then we have the inputs, and this is the transmission type. Again, now the transmission's a little different. We're just going to check for a mismatch. If there is a mismatch, then we'll take between the input and the actual type of the transmission. Then if there is a mismatch, then we'll set the raw. Actually, I think I want to do this a little bit differently because this value is, we're not going to know what that value is. So I think that's a bug there. So we actually want to do a check between the raw value and the transmission type. If this is changed, then we want to set that. Yeah, that's what we want to do there. That's the bug. Otherwise, that would never change. So what we're going to do here is we're going to take the input. Right, we're going to check that. We're going to check this against the raw. If the raw is changed, then we put the raw in, right, and then this will get changed on the physics thread. No, I don't want to change it here. I just want to change this all on the physics thread. Okay, so that should be it for inputs for transmissions and transmission simulation. So next up. Physics thread, again, nothing really here. We really aren't going to be touching this. Actually, there is something that we can actually do on the physics thread here, which has to do with the transmission. And that is actually on this. We're going to go ahead and set the simulation state for the current gear. So as you can see here, we're missing a variable. So let's go back and set that missing variable in the state. So this is going to be the current gear. This is a way for us to get this value to see what the actual current state of the transmission is when it's been updated on the physics thread. So to do that, I'm going to go up to where's our network traits, and I'm going to come down to our simulated state here. So this is everything that we're currently doing for the simulation state for all of our other vehicles. So we'll go ahead and update this as well here. Okay, so our wheel state, or our vehicle state, I should say, is in the vehicle movement traits. So let's come to vehicle movement traits. So this is the inputs. So, but this is the state. So this is our vehicle state. And this is us making sure that we have an updated state value for our vehicle at all times. So I'm just going to go ahead and copy this over. So this is going to be the current gear that we're currently in, and that's where I'm going to put that there. So again, blueprint read writable, so I can get access to it in a blueprint if I want to then output this for other things. So that's the current gear. Alright, so that should tie that up, and again, red squiggly goes away. Is there anything else in here that I want to I don't really want to add anything in here at this time. Again, there will be a lot of other things that we're going to add into here when we get more into suspensions and wheels, but for now that's the only thing that we're just going to be updating to make sure we have the most current gear that we're in. All right, so next is going to be apply inputs. So we have some new inputs, and when we did this originally, we had the engine simulation, right? But now we have the transmission simulation. So what I'm going to do is I'm going to go ahead and check for both the... And to do that, I'm going to do a simple little AND operator. And I'm just going to do a check to see if the simulation for the transmission is enabled. So 1 and 2, there it is. And as you can see, we've got, I've got the simulation throttle, got a little bit of black space here. So I'm going to go ahead and add the transmission data in. And this is going to be mostly for if you're a manual transmission, but you could also use it if you wanted to simulate popping from neutral to drive, or from drive back to neutral and then into reverse. You could do that too. So again, engine simulation is enabled, transmission is enabled. We're going to check to see, this is where we're going to check the updates here and here now. So if this is set, if these are not in alignment, then we'll switch them. And as you can see here, because this is a integer 8, we need to cast this to the actual enumerator so that we can go ahead and put that back into the transmission type to set the transmission type to its new transmission type. For simulation inputs, we're just going to go into the simulate transmission simulation and hit the upshift. For downshift, we'll do that. And then as you can see here, we need to consume this, right? Once it's used, we'll consume it here. So that we're not hanging on to it. And the reason why we want to consume it is as soon as we use it, we don't need to hang on to it in order to keep us going or keep us moving. Otherwise, if we hanged on to it, the second time we come down, we'd keep shifting up and up and up until a new network packet came in to set that to false. So we just want to make sure that as soon as it's used, it's consumed, and then we move on. All right. As far as anything else, I'm going to leave. We don't need to add anything new here. And we don't need to add anything new, I think, to the wheels. Let me just double check. So we have the braking. Brake torque, steering. We're not there yet. Alright, so no, we don't need to add any inputs here for the wheels, so we're just going to keep this for now where it is. But I think we are done for the inputs for the mechanical, for the engine. So again, transmission, upshift, downshift. So that's what we're going to do there. Let's scroll down. We're still in, okay, now we're still in, this is the update simulation, so this is where we actually apply all the forces. So we're really not I'm calling this run mechanical simulation because we're not applying any forces here. We're just running a simulation which will generate the data that we need to then turn that in from mechanical data into force. Alright, so now let's come down to our mechanical simulation. So in the mechanical simulation, in the previous video, we went ahead and did the engine simulation. So again, I'm also going to put a check for the transmission. So I'm just going to add that code back in. So as our transmission there's enabled. So if both are there, we can go ahead and do that. Run simulation, powered. Again, this is us trying to figure out what the current wheel RPM is. So if our vehicle is rolling downhill, we want to make sure that we've got that current RPM that we can feed into the engine. If it's from standstill, again, as we're accelerating, we want to take the shaft rotation, right, and translate that back into the engine for us for this simulation anyway. And again, I'm just to make sure that there's no bias in the system, since we're taking this from wheels. I just want to make sure that we'll take all of the wheels that are currently providing power to the simulation, right, because this is only relevant for wheels that are connected or in gear with the simulation to provide that RPM. So we'll add them all up, and then we'll divide by the number of wheels that are powered, and then we'll get us the average. That's how I'm deciding to do that. And then I got a little message here, so I can feed that back out to see what that is. And then what we have here, and so I commented this out because we didn't have this at the time, but now we do. We now need to feed some information into our engine simulation, so it's a kind of like a simulated feedback loop. So we have the data coming in from the throttle position, but we also need some additional information coming off the transmission, so we kind of feed the engine state. So we can go ahead and finish off our engine with the transmission. So again, this is the wheel speed coming in, and this I'm using this so that I can get some, just look at some additional data as well to make sure that we're spinning. But all we're doing here is we're just taking that information, and again here we're just putting in the average RPM into the transmission, checking to see if we're out of gear or if we're in gear, and depending on that, that will then set the engine RPMs. And then once those RPMs are set, we'll simulate, and then this will then get us the current RPM of the revolutions per minute of the engine coming back out. All right, so that's revolutions. So next up is going to be the transmission. So we want to simulate the transmission. So this is the current engine simulation based off what we currently have. So now we need to simulate the information coming off the engine and pass that through the transmission, so that we can get our angular velocity and our angular and our turn angle on our wheels. So, and I'm just going to include the message as well. So here is just, again, we're taking the current RPM, setting the current engine RPM in the transmission. We're going to tell the transmission that it's still allowed to change gear. And then here, this is just purely for figuring, just checking the gear ratio to see what gear what the gear value is coming off the transmission. So I've just got that for just debugging purposes. If you don't want it, you can always just release that. The only two things we really need right now is this and this. And then after that, we need to then run the simulation and get the torque. So again, we're going to simulate the transmission. So this will simulate whether we need to shift or not, or whether we're manual or automatic. And again, we're passing in the delta time that's coming in from Run Mechanic. And then this should give us the transmission torque. So this will be the final torque that's coming off that transmission that will be then passing into the wheels. So now so what we were doing up here is we're calculating this average RPM from the engine to the wheels. But and this is what we're going to be using to actually see if our vehicle is overspeeding. So we have a maximum RPM that our vehicle can achieve, right? But technically, we could be, you could technically have an overspeed in which your vehicle's going faster than the transmissions, the revolutions on the shaft can provide. So to do that, if we are starting to overspeed, then we'll just set the transmission torque to 0. Because that's effectively what's happening. There is no torque at that point. It's just effectively all zeros. And then after this, we just need to add one more piece, and this is going to be based again off our wheels. So this is where we can start applying that torque to the wheels. So I'm just going to take this, and we've got a new function, and I just need to set that to use our wheel class. So I'm just going to change that to new vehicle wheels. So this is our class, and this is the class that we're going to be putting into that array of wheels that we've got. So later on, when we get to the actual wheel system, we'll be creating all the wheels. We'll be putting them into an array to manage them, and then that's where we'll be running the wheel simulation off here. But for now, we're just going to it's right now it's just an empty array, but again, this is where we'll be keeping all those wheel instances that we'll be simulating. So we'll iterate through the wheels. From there, we'll go ahead and check to see if this wheel is engine enabled, right? If it is engine enabled, then we'll go ahead and set the differential here using the differential equation. And then what we'll then do is we want to take the transmission torque coming off and we want to convert it from Newton meters into Newton centimeters, right? So if it's in Newton meters, we need to go, so Unreal Engine works in centimeters per second squared. That's how it calculates thrust and velocity. So we have to scale it from meters down to centimeters so it can be properly applied. So if you're kind of working on any simulation, right, and you're wondering why you're having, you're putting these, you're putting numbers in which just don't make sense. Maybe it could be that there's a scaling issue there, and you just need to either up it or down it. So that's what we're going to do here. We're just going to make sure we scale this from meters to centimeters. So let's go ahead into our utility function and set that up. Okay, so in physics simulation utility, this is where we're keeping all of our conversions. So as you can see right now, these have been our rate conversions. We've added our omegas here, so when we were doing the engine, so we could translate from RPM to omega and back again. So here, this is where we're going to add two new functions where we'll translate from Newton meters to centimeters and back again. So I'm just copy these over, add them there. All right, so we have Newton meters to centimeters and Newton centimeters to meters. This is just the equation to just do that do that conversion for us. And now when we come back to our components, that should go away. All right, so good. So we've got everything set up here. So this is going to take the torque, right? And then if we are power enabled, we'll take that torque and we'll pass that through the differential to figure out where we want to apply that, which wheels we want to apply the power to, that torque power to, right? And then if it's a wheel that is not powered, then we're going to set the drive torque to 0. Pretty simple. Okay, so the only thing we have left now is to set up our input functions. So I'm just going to come in here and we'll just go ahead and fix these, and hopefully Visual Studio will put them in the right place, in the right file. All right, looks like it has. All right, so let's go ahead and just fix this real quick. So again, I'm just going to use a boolean to determine whether we want to set this, which one of these we want to set to true. That's all I'm going to do there. And then as far as if I want to change this mid-game, that's the transmission type. And again, we'll just take the enumerator and we'll just pass the enumerator into there. Since we're going from enumerator to integer, that conversion will automatically get made. We don't need to worry about casting it. It's only when we want to cast it back from integer back to type does that really need to be, does that become an issue. So we're fine there. All right, so I think that should do it. The only thing we should do now is just compile and make sure we don't get any errors. And then we should be ready for our next video, which will be, I'm thinking, our next video, I think we should just go ahead and get into steering. And then from there, we can then talk about how we want to animate, run animation. So if we get the steering done, then that should be everything we need for mechanical. And then we'll need some animation support. And then after animation, steering and animation support, we can then start looking at getting into the fun stuff, which is suspension and wheels. All right. So let's quickly do a compile and see what happens. Alrighty, so let's go ahead and check the compile. Again, make sure I'm going to make sure that live enable is off so I don't get any surprises when I try to reopen this project. Going to hit the little compile button, let it compile. Alright, good compile. Alright, cool. So yeah, I'm going to call it for this video. This is everything. We've got transmissions and differential in there, so we've now been able to take a throttle input, simulate torque off the engine, and then convert that torque through a transmission simulation into power to the wheels. So now we've got that. I think the next video, let's go ahead and finish off all the mechanical things by doing, we'll do a steering simulation. And then I think after that we'll do some animation support so that we can get around rotation locks, especially when we're, and how we can fit that into skeletals. And then from there, we can also then go into the following video. We'll start looking at probably suspension, so we can get the vehicle to bounce up and down, and then from there we'll go finish off with wheel frictions. And that should then give us everything that we need to drive a vehicle around the desert. Alright, so as always, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel, and I will see you again in the next video. Cheers, and have a good day.